So now we've learned about matter. All matter are solid or liquid or gas. These are the phases that matter can be in. An example of a solid is this pen. It's a solid object. An example of a liquid is the water in this bottle. As you can see, that's what a liquid looks like. And an example of a gas, if you breathe in and breathe out, that what you just breathe in and what you breathe out, that is gas. Everything around you is gas. Alright, so let's draw some boxes. If you could please take out pen or paper maybe. This is just a simple exercise to generally distinguish the differences between each of these phases. Alright, so for solids, they are, the question is, how much space should be in between each atom? Just use circles as an atom. So this pen, you see I'm tapping on it. I can't really put my finger through it, which means there's not enough space for my finger to go through this pen. Or this whiteboard. This is also a solid object. So we can assume that the spaces between the atoms could look like that. They're very small spaces. Okay, now how about a liquid? Have you ever put your hand inside a pool of water or under the faucet? Maybe when you're taking a shower or a bath, you notice that the water it's easy to put your hand in that water compared to this pan. You can't do this. You can do this with the water. You can put your hand in the water, but you can't do that with a pen. So, knowing that, we can assume that the space between each atom is a little bit more. Alright, so we have solid and liquid. Now gas. If you put your hand through gas, and as I said before, gas is everywhere. It's basically the environment. We're breathing it in all the time. So, as you can see, I'm putting my hand through the gas. It's much easier to put my hand through gas compared to liquids. So, we can assume that there's much more space in between each gas molecule. Much more space. So now we can see the differences between the atoms, the spacings of the atoms for each phase of matter. But let's now get to more specific details. Not too specific, just general details to help us understand what defines a solid, a liquid, and a gas. So let's use this pen as the example for a solid. See this pen? No matter what I do to it, I can drop it, I can toss it in the air. Well, the shape of the pen stays the same. So that means the pen has a definite shape. Alright, so how about the space it's taking up, or also known as the volume? This pen, I just shook it around, I just dropped it. Did the space it took up change at all? Or the volume? No, it still has the same volume. So it is a definite volume. Alright, how about a liquid? So in this water bottle, you can see the water in there. It ends up, let's just put our finger right there. When I tilt the bottle this way, the water will be right there. That's the amount of space the water takes up. So now I'll shake the bottle, shake it. This shows that the shape is changing when I shake it. Alright? And so when I tilt the bottle, water is still taking up the same amount of space. So water has no definite shape, or liquid I mean. And it has a definite volume, because it didn't matter if I shook it or not. The volume, or the amount of space the water took up, stayed the same. So let's move on to gases. So in this water bottle, we see that over here there's nothing. Possibly it could be squeezed very tightly. Okay, so it's not easily squeezed together very tightly or compressed. And the reason for that is because there's gas here. And so the gas, it takes the shape of the container, which is the bottle. This is the shape of the gas right now. And I can manipulate it however I want to. So that means gas has no definite shape. And guess what? The volume, the space it took up, it changed when I squeezed this. It's taking up less space right now. And now it's taking up more. That's because the gas particles, they like to go as far apart. They like to take up as much space as possible. As you can see, the spacing between the atoms, they want to be super far apart compared to the liquid and compared to the solid. And so it also has no definite volume. And so now we have a general idea of each phase of matter. Alright, so now we know generally about what a solid, liquid, and gas look like. And we can distinguish what objects are a part of each phase of matter. But we should know what it is called to go from each phase of matter. So from a solid to liquid, from a liquid to gas, and then backwards. So let us start off with solid. So from solid to liquid. What's a good example of some element or compound or substance that goes from solid to liquid that we might see every day? Water. What's the solid form of water? Ice. Yeah. Maybe you see ice cubes in your drinks sometimes, or all the time. So, solid ice, when you go from solid to liquid, what could that be called? Yeah, it's called melting. But you should know another name of it, which is called fusion. Alright, now from liquid to gas. So we got the ice cube. Now it's water. Alright, how do you get from liquid to gas? Think about where you might have seen it. Hint, it's in the kitchen. Well, from liquid to gas, you would usually see it in a pot and it's boiling hot water. So if you've ever seen a pot, right above the pot there is steam. That steam is water vapor. And like what I just said, water vapor, the process of going from liquid to gas is called vaporization. Alright, so now we know what it's called to go from solid to liquid to gas. Let's go backwards. From the gas to liquid, what can that be called? It's called condensation. Now from liquid to solid, what can that be called? This one's pretty easy. From liquid to solid, which is an ice cube. Yeah, freezing. But there's another term for that you should know. It's called solidification. Okay, now we know how to get from solid to liquid to gas, and from gas to liquid to solid. But there are some instances where we don't have to go through the liquid to get a solid to become a gas. Now, what can that be called? This is a very hard word. The word is sublimation. Maybe you have heard of dry ice. Dry ice undergoes sublimation in room temperature. That's why it immediately goes to a gas form. So that is sublimation, going from a solid to a gas. Now, how do you go from a gas to a solid? What could that be called? Well, it is called, I'll write it over here. It is called deposition. Alright, so now we know the names of all the phase changes